Things that hit the Earth. The Earth is constantly bombarded by stuff from outer space, lumps ranging from dust through boulders to quite large asteroids. These things that hit the Earth are called meteoroids. And everything that hits us does so at a minimum of 7 kilometers per second. So even small meteoroids can put on a show, and big ones can be quite devastating. One impact a long time ago caused much of the Earth to explode into space and melted what remained. We will look at the effects of different sized meteoroids. The numbers and sizes of meteoroids have decreased over time, but even now the Earth is hit by an average of 50 tons of extraterrestrial material per day. The impacts can be seen by anyone with a few minutes to spare on a clear night. 50 tons might sound like a lot, but spread out over the whole Earth, it would take about 1 billion years to form a layer 1 centimetre thick. And it doesn't mean that the Earth is getting 50 tons heavier each day either. About 300 tons of hydrogen escapes into space every day. Most meteoroids are protoplanetary material and collision debris from the asteroid belt. Dust-sized particles have very little inertia and so slow down quickly in the upper atmosphere without being vaporized or producing visible light. They then spend a few years circulating in the atmosphere before finally settling on the ground or in the sea and joining all the dust that comes from terrestrial sources. Particles the size of sand grains to pebbles take longer to slow down and release their kinetic energy as heat. This heats up the particle as well as the surrounding air, making both glow. This happens between about 70 and 130 kilometers from the ground. Even at that height, we can see the glow from the ground. The phenomenon is called a meteor by astronomers, a shooting star by normal people. If you look up on a clear night, you will see about one meteor every 10 minutes on average. During meteor showers, it is sometimes possible to see a lot more than 10 per hour. The sand to pebble-sized particles that cause meteors generally break up and partly vaporize during their descent. The remaining dust falls slowly to the ground. Objects the size of stones and boulders produce very bright meteors called fireballs or bolides. These can be brighter than the full moon and can last for several seconds. Some of these reach the ground fairly intact. Others break up during their descent into smaller pieces, some of which can reach the ground. Meteoroids are mostly made of rock, though some are made of iron, and on occasions a comet, consisting mostly of ice, can hit the Earth. A rock or iron meteoroid that hits the ground is called a meteorite. Don't confuse these three words. Meteoroid is a natural object from space that enters the Earth's atmosphere. A meteor is the flash of light produced when a meteoroid passes through the atmosphere. A meteorite is a meteoroid which has landed on the ground as a visible lump of rock or iron. Meteorologist is someone who studies the weather. The connection is that meteorologists study rain, hail, and snow, which fall from the sky. People have been hit by meteorites. In 1954, Anne Hodges of Sylacauga, Alabama, was hit by a 4-kilogram meteorite that crashed through the roof into her living room, bounced off the radio, then hit her on the leg while she was having a nap on the sofa. She was badly bruised, but still able to walk. In 1927, in Aba, Japan, a bean-sized stone landed on the head of a 5-year-old girl without hurting her. It was found resting on her headband. There haven't been any reports of people being killed by meteorites, but in 1911, the Nakla meteorite killed an Egyptian dog. A meteoroid 10 meters across coming in at a steep angle would generally hit the ground, either in a single piece or in a shower of fragments. A single piece would make a small crater, maybe a few meters across and a meter or so deep. Fragments would make smaller dents. The total energy released during the flight through the air and the impact with the ground would be the equivalent of a 200 kiloton atomic bomb, about 15 times the size of the bomb that was dropped on Hiroshima. A meteoroid 10 meters across coming in more parallel to the ground would more likely break up in the air, producing a bright fireball and a shower of fragments, some of which might evaporate, others of which might reach the ground. In 2013, a meteoroid 20 meters across broke up about 30 kilometers up in the atmosphere over Chelyabinsk in Russia. It produced a fireball brighter than the sun, and the shockwave from the explosion damaged 7,200 buildings and injured 1,500 people, mostly through flying glass. In 1908, a meteoroid about 65 meters across, possibly a comet, broke up in the atmosphere over the Tunguska area, again in Russia. Being in a very sparsely populated area, no one witnessed it, but it flattened 8 million trees over an area of more than 2,000 square kilometers. A meteoroid 100 meters across would very likely hit the ground, either in a single piece or as fragments dispersed over just a small area. As a single piece, it would make a crater about 3 kilometers across and 500 meters deep, like this crater in Arizona. The total energy released would be the equivalent of a 200 megaton atomic bomb. The impact would cause a magnitude 6 earthquake. It would also cause a fireball 4 kilometers across. From a distance of 10 kilometers, the fireball would appear 40 times as bright as the sun. At that distance, trees and the observer's clothes would catch fire, and the observer would receive third-degree burns to the side of their body facing the blast. The observer would then be hit by a blast wave and later on showered with rocks and dust ejected from the crater. A meteoroid 1 kilometer across would make a crater about 20 kilometers wide and 750 meters deep. The total energy released would be the equivalent of a 200,000 megaton bomb. The impact would cause a magnitude 8 earthquake. It would also cause a fireball 40 kilometers across. At a distance of 100 kilometers, trees would catch fire and the wind from the blast would reach 1,100 kilometers per hour. This would uproot most trees and knock down most buildings. A large amount of rock and dust would be ejected into the atmosphere, producing an effect comparable to a major volcanic eruption. The ground at 100 kilometers would be covered with debris to a depth of about 50 centimeters. A meteoroid 10 kilometers across would make a crater about 160 kilometers across and 1,500 meters deep. The earthquake would be magnitude 10.2, larger than any earthquake ever recorded. The shockwave would stimulate earthquakes and volcanic eruptions in other parts of the world. The blast would cause trees to catch fire and buildings to be knocked down more than 1,000 kilometers from the impact site. So if such an impact happened in Sydney, Brisbane would be demolished. 5,000 cubic kilometers of rock would be melted or vaporized, and half of this would be ejected into the atmosphere and surrounding space. Fireballs would rain down over the whole Earth, causing widespread forest fires. Dust and smoke would encircle the Earth and darken the atmosphere for several years, or even decades. Temperatures would drop by 10 to 20 degrees worldwide. Crops and forests that had never known temperatures below freezing would die from frost and snow. Cold, famine, and the fight for scarce resources would kill most of what remained of mankind. This is about the size of the asteroid which hit Chicxulub in Mexico 65 million years ago. The Chicxulub impact happened in the sea, but that would have made a little difference because the water in the area would have been vaporized. Being in the sea, however, would have added a tsunami to the general mayhem. The wave would have been over a kilometre high near the impact zone, reducing to 20 to 30 metres 1,000 kilometres away. The changes that followed the Chicxulub impact are thought to have caused the extinction of about half the species of life on Earth. This includes all the dinosaurs who were, until that time, the dominant life form. Of course, there is an alternative theory as to why the dinosaurs became extinct. This table shows how often meteoroids of different sizes hit the Earth. Of course, these figures are for the present era. In the first few 100 million years of the Earth's history, there were many more impacts than there are nowadays. The largest impact was when Theia, a planet about the size of Mars, hit the Earth, causing much of it to explode into space and the rest of it to melt. Part of the ejected material gathered in orbit around the Earth to form the Moon.